Situated on the beautiful west coast of Norway, the city of Stavanger is Norway's fourth largest city, and together with the surrounding districts, it has a population of around 275,000 who produce a similar amount of waste to towns like Telford and Reading. In line with European laws, the local authorities are required to deal with the waste created by their residents, and this short film shows how the Energos energy from waste technology is successfully employed to complement their policy of source separation to achieve significant reductions in the amount of waste being landfilled.
Waste is disposed of in 3 separate bins, one for garden and kitchen waste, one for card and paper, and the other for the residual waste. Households are also encouraged to recycle bulky and other wastes at one of several bring sites or household waste recycling centres. Kitchen and garden waste is collected and delivered directly to the composting plant, whilst paper and card is recycled back into the paper industry. During 2005, 110,000 tonnes of MSW was produced by the residents of Stavanger, of which an impressive 54% was recycled.
The remaining residual waste is collected and delivered directly to the Energy from Waste plant, which is located in the suburb of Forus. Using the Energos gasification technology, the energy potential of this non-recyclable waste is recovered to provide local heating and electricity. This proven system was designed in Norway specifically to provide a low-emission and economic process for small communities, typically found throughout Scandinavia. But its ability to complement a recycling-based strategy also demonstrates how it can provide the ideal solution for towns and cities, reducing the size of the facility that would normally be required.
Designed to deal with real waste, the Energos plant eliminates the need for additional, expensive and complicated pre-treatment. Locating the plant in a suburb allows the residual waste to be delivered directly by the collection vehicles, reducing the need and costs of transfer stations. This approach provides the authorities with the ability to minimise the cost to local taxpayers.
The crude residual waste is delivered to the plant via an automated weighbridge and unloaded into the reception bunker. The pre-treatment operator supervises the unloading of the waste and, using a manually controlled crane, transfers it from this bunker into the shredder. The shredder reduces the waste into a more manageable particle size, which enables a more consistent and thorough treatment process in the gasifier to fully recover the energy and produce a very low carbon ash.
From the shredder, the prepared waste is passed along a conveyor belt and under a magnet where ferrous metals are removed. These metals are collected in skips before being sent to a specialist metal recycler and returned into use. Typically, the amount of metals recovered from the waste stream is around 3%. Having passed under the magnet, the prepared waste is then delivered into the fuel bunker, where additional mixing is carried out by an automated crane. On a signal from the gasifier, fuel is automatically dropped into the fuel delivery screw, which transports it into the gasifier feed chute.
Through a series of automated signals, the waste fuel is delivered to the gasifier feeder. A hydraulically driven ram plunger feeds the fuel onto the grate of the gasification chamber, and a guillotine controls the depth of waste fuel on the grate. The quantity of primary air that is delivered to the 12 individual grate sections is carefully controlled and distributed finely across the entire gasifier grate.
Hydraulics are also used to drive the transport system that moves and mixes the waste fuel as it passes across the grate. The Energos control system ensures that only partial oxidation, referred to as gasification, is undertaken in the primary chamber, but so thorough is the process that by the time the waste reaches the end of the grate, the carbon has been effectively removed. The syngases produced in the gasifier are then transferred into the secondary oxidation chamber, where secondary air and recirculated flue gases are added. In this chamber, complete and thorough combustion of the syngases is carefully controlled to ensure that at the same time, NOx formation is minimised.
The fully oxidized hot gases exit the secondary chamber via a duct before entering the boiler. The first stage of the boiler system comprises a compact water tube section of 4 separate tube bundles. This part of the boiler operates in the most arduous conditions, and so the tube bundles have been designed to be easily removed and repaired, and to facilitate cleaning. By using steel shot balls that cascade down through the boiler tubes, Energos successfully manages the sticky deposits that would normally foul the boiler surfaces.
After the tube section, the flue gases pass through the remainder of the compact boiler system, which is designed to rapidly cool the gases, minimizing the reformation of dioxins. After passing through the economizer, the flue gases enter the treatment system.
Lime and activated carbon are injected into the flue gas prior to the baghouse filter to neutralize and absorb the acid-forming components and remove metals. The compact boiler design and the baghouse filters also ensure that dioxin emissions are a fraction of the allowable limits. Typical emissions from all the operating Energos plants are consistently and significantly lower than the EU directive limits.
The energy recovered in the boiler system is used in the combined heat and power plant. This provides heat into the local district heating network and uses the surplus energy to produce electricity. During the winter period, the majority of the recovered energy is used in the district heating system, supplying energy to commercial and industrial customers in the adjacent business district. Since the completion of the Energos plant, the heating network has been continuously expanded, and one recent extension was into a new residential estate where heat is delivered through a meter to each individual house.
During periods of low heat demand, the steam is used to produce electricity through a turbo alternator. The electricity is sold into the electricity distribution system and used by local consumers. The proprietary Energos control system provides the plant operator with a comprehensive overview of all the plant's operating conditions.
The capacity of the plant is about 40,000 tons per year. That translates into some 125 tons per day. If this plant had not been in operation, the waste would have been deposited on a landfill. Since the plant was put in operation, that's 4 years ago now, we've had no complaints whatsoever.
There are many advantages to using the Energos technology. It fits extremely well into a recycling-based strategy, provides a local solution for local waste, helping to reduce waste miles and local traffic in the immediate area, eliminating the need for transfer stations and sophisticated and expensive waste treatment plants.
With a skyline that does not dominate the surrounding area, and with its low and stable emissions, the Energos plant is more acceptable to the local population.
As a gasification technology, the electricity income is enhanced by renewable obligation certificates, and with over 10 years operating experience at 6 plants, the technology is proven.
Also important is the plant's ability to process different wastes. The 6 plants operate on a variety of wastes, including MSW, residual MSW, commercial waste and residues from MBT plants.
Energos, a proven and practical solution.